All right, good evening, everybody. Um, in this tutorial, we are gonna look at Math 2100 tutorial sheet 4, and just gonna be looking at these questions here. Gonna solve from question 1 to question 7 in this tutorial. Right, let's all jump into it. Okay, so the first question says, find the values of C prescribed in the Rolle's theorem for the given function on the interval. So we have the function, then we've been given the interval as well. Then they're telling us to find the value of C for the Rolle's theorem. So first we ought to understand what the Rolle's theorem is. So we say for a continuous function f on the interval A, B, meaning it has to be continuous on this interval, including the points A and B, and it has to then be differentiable, saying differentiable on the open interval A, comma B. So continuous here, then differentiable there, then and we're saying that f of A being equal to f of B, then there must exist. So these are the three conditions: continuous on the closed interval, differentiable on the open. When we evaluate we evaluate the function at A and the function at B, they are equal, then there must exist some constant C or some value C that is in the open interval A, comma B, that is in the open interval, with which when we say f of C, this must be equal to 0. So we're saying then there will exist a C in this interval such that the f prime of C we're saying is equal to what? To 0. Is equal to 0. So this is what we're going to apply here in order to calculate or to find the value C. So this is important to know that if this is true, we can use this here, evaluated at C, that then we get our value C, and see what value C that when we differentiate gives us 0, or that evaluated at C will give us 0. So we use this concept here in order to find there. Okay, so what do we do now? So first of all, when you look at these function, polynomial functions, quadratic functions, these will be differentiable at, will be continuous on the what? On the entire interval here, because whatever you put that is in that interval. So our interval here, which we're being given, we're working between 0 and 2 to the power 3, like that. So this is what we are given, and a polynomial function, this here will be continuous here everywhere. So it's continuous. If you want, you can sketch this here, sketch the cubic function there, and you see that you just have a smooth kind of curve that is going to be there. So meaning it's going to be continuous there. It has no breakages, it has no discontinuities. So 1 is true. Differentiable, can we differentiate from this here? You can clearly see that you can use power rule, the power rule here just to differentiate that, so it's differentiable there. So we jump straight into checking, is this true here? So meaning I want to check, is f of 0 going to be equal to is it going to be equal to f of 2 root 3, like this? So I don't know this. Yeah, I don't know yet, so hence the question mark. So let's try it. So of course, when we say f of 0, you already know that f of 0 replacing into that there is just going to give you 0. So we go straight, then we do f of 2 3, like this. What am I going to get there? So where there is x, where there is x cubed, I put the root 3 like that, cubed, then minus 12, then I have 2 root 3 like that. Then here now, I have to evaluate that. So what do I get on the first one? In the first one, remember it's 3, so this is 2 to the power 3, and you also have root 3 to the power 3. So this here gives us 8. Then you have so 3 by 3, root 3 by root 3, you remain with a 3, and you have a root 3 remain here. So you multiply the 2, we get 24. So that just gives us 24 root 3. Then from here now, the other one, what does it give us? Here also, this will just give us 24. That will be 24. 24, then of course root 3, and this gives us 0. Okay, so we've checked this other one. So we know now that f of 0 is equal to f of 2 root 3. So this constant c meaning must exist, and of course that this here is what is true. So now how do we get, so the conditions all hold, so how do we get that? So we use this same fact to say that f prime of c is equal to what? Is equal to 0. So we'll get our function, the function which we have there, we differentiate it and equate it to what? To 0, and find that constant, what? C. So what I'm going to do, so let me erase this part here. Okay, so now okay, so after getting that there, so we now differentiate. So say f prime, you can say f prime of c, f prime of, okay, let's say f prime of x, then we'll replace the c later. So then that gives us 3x squared, just using the power rule, minus 12, like that. So this is what I get. I can even factor out a 3 here, such that it comes like this, and therefore like that. So this is what I get. And I'm saying now, f prime of c, so meaning where there's x, I already replace c, then I just have that c squared is equal to 4. This here must be equal to what? To 0. So you're saying this equal to what? To 0. Okay, so now what does this imply? For us, this just implies that c squared, if I divide the 3 to 0, it just gives me 0. So I remain, this will be 4 equal to what? To 0, like that. So this is c squared equal to, the 4 goes the other side, then you have c is going to be plus minus 2 when you evaluate. Now, they're telling us to find the value of that c, and look at the interval which we've been given. We're working with a positive interval, meaning we can't have a negative value. Thus, our c is just going to be equal to what? To equal to 2. So this is our c. So if you want, you can test this c. You test this c in your in our equation, where we're saying that f prime of c is equal to what? To 0. So where there is this part here, where there's c, if I replace the 2, this gives me 4 squared. So in short, I'm going to have 4 minus 4, which gives me 0 when I subtract. So in f prime of c, we've seen that it has given us the 0. So this holds. So this here is our what? Is our c. All right. So we apply the same to the next questions. Okay, so let's do the same for the next questions. So now the next one is, we have sine. We know the graph of how sine looks, so it's continuous. We know it's differentiable because I can differentiate this sine x here, and I know what it will already give me. So we're working between the interval 0 and pi, 0 and pi, which is just 0 and 180, 0 and what? And 180. So sine 0. So the first I evaluate, so sine 0 gives me what? Gives me 0. And also sine pi gives me 0. So sine 0 gives me 0, and sine these give me all 0. So meaning f of 0 is equal to what? F of pi, like this. So they give me this. So now what do I do? So I say I differentiate the function. So f prime. So I get sine. I differentiate sine. I get cosine of x. So f prime of c of this is going to just be f of c. Then I'm saying this cos c equal to what? To 0, because this is what is given there as the condition. So now if I say c, this is cos inverse of 0. And what does cos inverse of 0 give me? Cos inverse of 0 just gives me 90 degrees, which is just what? Pi over 2. So my constant, or my c there, is just pi over 2. All right. Next, we have a function cosine. Also, we've seen the graph of cosine before. In case somebody has not, it looks like this. So this will be for a single period. That is between 0 and what? And 2 pi. So if you go again like that, you see that this it's just continuous. It does not have any discontinuities. It can already differentiate that. So I go for the other conditions to check now. So I'm going to check. So cos pi over 2, if I replace this here, I know I get 0. This is just cos 90 is 0. I do again cos 3 pi over 2 gives me 0 also. So this just says that f of evaluated at pi is equal to f evaluated at 3 pi over 2, and this gives me 0. So that is true. So I get f prime of x, and that gives me negative sine x, like that. So now, after getting this negative sine x, I say f prime of c is just going to be negative c there. Then this equates to 0. That 0 divided by 0, I just get, by negative, I get sine c is equal to 0. C, then sine inverse of 0 here. What does sine inverse of 0 give me? So I have, okay, so I'm saying, right, so sine inverse of 0. And that gives me, so this we know can either give us a 90, can give you 180, that is sine 180 gives you 0, or sine 0 itself gives you what? Gives you 0. So meaning what can give you this is either pi or 0. So now looking at the interval which we've been given here, we see that the only one which is in between there is what? Is pi. So pi is what is in between and not 0. So meaning we go for the one which is pi. Okay. All right, so move on to the next question. Next question is saying, does Rolle's theorem apply to the following functions? So now, to the following functions, let's see if they do apply. So you have f of x to be equal to x, so x squared minus 4x over x minus 2. And this here, factor out that x on top, I mean it's x minus 4. Then I have x over what? Over 2, like that. I just factoring it out anyway. But when you look at this function, it's a rational function. And you always check the bottom here for a rational function. And you see that it will have a discontinuity. So first of all, just checking on the fact that is it continuous at every point, since they did not give you an interval, so you check for every point. So is it continuous at every point? And you see that it will have, when x is equal to 2, this function becomes discontinuous because it will give you a 0 here down, and that will be undefined. So meaning we cannot have x. We can't have x equal to what? To negative 2. X cannot equal to what? To negative 2. So what does this simply mean for us? So this means that we cannot apply Rolle's theorem on this. It's not continuous everywhere. Yeah, so it just fails on that. Next, you look at this one. Also, it's not continuous at negative 2. So that also is going to fail. Rolle's theorem can't apply on that one. Okay, next, they're telling us to find the value of C prescribed by the mean value theorem given that this and that equal to that. Okay, so the mean value theorem, so you ought to know that f prime of C, some value C, just the same as the one we're talking of when evaluated. So you're saying f of B minus f of A. This here is B minus what? Divided by B minus what? Minus A. B minus A. You can see that this actually even just looks like the formula of, that's the slope of what? Of a line. So that's what you're doing here. It actually even affirms that the slope of a line is just when you differentiate and evaluate it at that point where you are, then you get the slope at that point. So now, in this case, we've been given our A, we've been given our B. So now, that's the first thing we do. Let's find f of B and let's find f of A. So f of B, or let's start f of A, replacing 1 there. So I remain with 1, then plus 4, that's 1 minus 3. So this here just gives me 3, that's 7, that's 4 plus what? 7 minus the 3, just still remain with 4. So I remain with 4 here. Then I go my 3 here. So that would be 3 to the power, 3 to the power 2 like that, plus 4 multiplied by 3 minus 3. So what does this give me? So this multiplied, 3 to the power 3 is just 9. And 9 multiplied by 3 gives me 27. 27, then I have plus 12. That gives me 39. Then minus 3, I get 36. So this is 36 here. So I have my f of b, f of a. I have a and b already. So now what do I do? So we're saying here, I replace them. So f of b, which is just 36, like that. Then minus f of a is 4. Then I divide my b is 3, minus my a is 1. So here this just gives me, so 34, I get 32. Then there I get 2, this gives me 16. So 16 is the value that I get here. But now we're saying I should find the value of C that represents what? That mean value theorem. So f prime of C, meaning I need to get f prime of C, and in the f prime of C, I have to have that C. We're saying that f prime of C is going to be equal to this part here, to the right hand side here. F prime of C is equal to the right hand side. Our right hand side we found to be 12. So now what's my f prime of C? So I get, so I say f prime, of course, it's going to be f prime of x. First of all, then I'll replace my c. So f prime of x is just, so 2 by this 2 by power root 2 by the 3 gives me 6. Then I have, that would be x. Then the other part there, I just have that would be 4. Then that's a constant, -2 is a constant, so I just remain with that. Then replacing this here to say f prime of c is going to be 6c plus 4. So easy. Meaning now my that f prime of c, I equate it to the right hand the right hand side. So meaning I'll have 6c plus 4, and this is going to be equal to what? To 16. 6c plus 4, and this is going to be equal to 16. So I can find the value of my c. Taking the 4 that side, I have c like this. If I take my 4 that side and subtract, I remain with 12. Then here, divide by 6, I just have my c is going to be equal to what? 2. So this is the value of the c that I'm looking for. All right, so let's move on to question 2, question B, I mean. So, but B, the function is here, x cubed. Then we have 0 and what? And f of what is there. So now, meaning my f of b, so f of b in this case is just f of what? 6. So f of 6, then we're saying f of 0, then there we're saying 6 minus 0. So what is this here? I put 6 there. If I say 6 cubed minus 0, then 6 minus that gives me 116 over 6, and this here just gives me 36. So that's what I get. F prime, so f prime of c, I go directly with c because I know I'll replace c there. So that gives me just 3c cubed. So this is what I get. So then I equate this to that there. So I have 3c squared equal to, and I'm going to have 36 there. So what is this going to be? Divided by 2. Divide by 3 on both sides, I get 12. Find the square root, then I just get c to be equal to, of course, it's plus minus root of 12, which is just simplifying to plus minus 2 root 3. But then my interval that I am working in is positive. So my c is just going to be 2 root 3. So this is what I get here. All right, next we have an interesting question there. So these are very easy questions to handle. Yeah, so we say f of x is just ln of x. So ln of x, so I do the same again. So I evaluate this, where there is x, I replace to ln. So what is that going to be? So I say, by saying that ln 2e like this, like that, then minus ln of 1, because there's 1 there. That's how the function is. Then I divide, now I'm dividing 2e minus 1 there. So what is this going to be? Here, by the laws of logarithms, it's multiplication, so I can split that into addition. That's like that. Then that would be ln of what? Of e, like that. So then minus, so we know that ln of, okay, let me write it still like that, then I go here. So this is just a value, so ln of 2 comes there. Ln of e is just 1, so I put plus 1 there. This here is 0, so the 0, then I remain with e minus 1. So this is what I get here. Then now what we're saying here is that when I say f prime, so f prime of x is going to be f prime. Who's there? Looking for. They are not here. There's no one who's here. No. All right. So f prime of c here is then going to be, that's just 1 over what? Over x. So when you differentiate that, you just get 1 over x. So now, meaning that my f prime of c, meaning is just 1 over what? 1 over c. So you're equating this 1 over c. So we're saying 1 over c, equating it to this side here. Then what is that going to be for me? So if I cross multiply, you see that I end up, so this implies that I'll have c, then ln of 2 plus 1, like that, is equal to 2e minus 1. Then c is going to be, meaning I'll have 2e minus 1, like that, then that will be ln 2 plus 1. So yeah, if you have a calculator, you can punch this into a calculator, then you find your answer. Since you know ln here is there on the calculator, you can use it. You have all these here, so you find the value to be there. All right. So question 4 says, use the mean value theorem to approximate root of 15, that and that there. So how do we do this? So we use the mean value theorem, of course, but linearization to approximate. How? So this, we are saying that you're saying that f, okay, so I'll say f of x. So you can say f of b, f of x, whatever in this case, is approximately just equal to, so this is going to be equal to approximately f of a, then x minus a. So let me then show it to say, if I say f of b approximately going to be equal to f prime of a, then okay, I think I left something here. So all right, so this here we're saying f of a plus then f prime of a, then x minus a, like that. So now this here, I can show it. It is the mean value theorem, because when you write this f of a here, then we say plus f prime of a, b minus what? Minus a. So what is this going to be? So all right, so this here is just, if I take that the other side, I have f of a minus f of what? B. Then this side I remain with f prime of a, like that. Then I have b minus what? Minus a if I divide. So I get this here, which is just similarly to what we have done, which we've done this side. All right, so that's what we get. Now, let us then work out this part here. How do we then do it? So that's the main concept we're going to use here. So, okay, so now the first one, we have root 15. They're telling us to find an approximation of what? Of this root 15. So from the way it is now, you always want to make your work easy. So I'll say I'll let my f of x be just root of x, root of x, because I can see it from here, like maybe they replaced it and they got 15x, like that. So you write it in this way. Then so then you want to choose something closer to it, a value that is perfect, of course, a perfect root. So I have 15 here. So something close to here is 16. So I want to choose my a to be such that it's going to be equal to what? To 16. So in short, this here is our x. That's why we wrote it like that. So that's our x. That there is what we've chosen to be what? To be our a. Such that from here, if I say f of a, my f of a is just what? F of a is 16. Replacing it there, I just will have what? We have 4. Because, okay, let me write it. Root of 16, this gives you 4. So I get this here. So now, getting that, what else do I want to get here? What I want to get is the f prime of what? This f prime of what? Of a. So how do I get that? So f prime. So I'll say f prime of x first of all. Then I'll replace the value of a there. So my f prime of x, when I differentiate this here, what do I get? So see that can be written as 1/2 power rule. Then I just subtract there. So you just get that that's 2. Then you have x, that will be negative. The negative can make it come down. Then you have 1/2 root, because this is half x like that. So this is what you get. So when I differentiate, I just get 2 root x like that. So after getting this now, what am I gonna do? What I'm gonna do is I replace my a, because I want a here. It's saying a, f prime of a. So f prime of a is going to be replacing here a, that gives me 4. 4 by 2 gives me 8. So I get 1/8. So that's what I get, 1/8. So now what else do I need? So I already have this, I have that. Oh, I need x minus a. So what's my x? My x is just 15. My a is 16. So this gives me -1. So I get that to be -1. Now it's a plug and chug game. Nothing hard about this. So you just say f of x, your f of x is approximately, and look, our f of x, what we say it to be. So that is just 15 here in our case. So it's 15. So I can even say directly, okay, so it's 15 there. So I can say directly to say, okay, I'll say root 15 is going to be approximated by, so f of a we found to be what? To be 4. So I place 4 there. Then I have plus f prime of a is going to be what? To be 8. Then I multiply this by -1. So this here is going to be equal to, so if this here just becomes 4, this will be 4 minus 1/8, and this here gives me 3.875. 3.875. So if you have a calculator, you punch in root 15, you see that you get something like 3.872983, which is close to what we have found there. Okay, so that's how you approximate that, and you use the same for the rest. But anyway, we still do it because you people pay money. Okay, so we have the 3.001, then I have 3 here. So this one, how do we then approximate? So always make your work easy. Let what's inside there, the value, the number that's there, just let it to be at your x. So such that f of x is going to be equal to x cubed. So our f of x is equal to x cubed. Get a number that's closer to the value which you are there. So what number is closer to 3.001? That number is just going to be what? To be that value, that number is what? Is just 3. So your a to be what? To be 3. So you let your a to be what? To be 3. So after letting your a to be 3, such that now when you replace f of 3, replacing there, 3 cubed is just going to be what? To be 27. So 3 cubed is 27. Then now you say f prime of x. So f prime of x is 3x squared. Then now you get f prime of what? F prime of a, because you want f prime of a. So f prime of a is just, a is 3. So you get 3, then you have 3 multiplied. So you have 3. Placing the 3 there, you have 3 squared. So that's going to be 9 by 3, which is just 27 also. So this is what you get. Then now, the change, that is the difference between x and a. So your x is what? Is this here. Your x is 3.001. Then your a is 3. So you're saying 3.001 minus 3. So what does that give you? 3.001 minus 3. Excuse me. Okay. So what do you get there? So when you subtract this, you just get that to be 0.001. So that's what I get now. Okay, then from here, what do I do? From here, it's plug and chug. So you have 3.001, which is like your f of x. This will be approximated by, so what's your f of a? Your f of a, which is f of 3 in this case, so that will be 27, then plus f prime of a is also 27. Okay, so f prime of a is 27, then you're multiplying it by 0 point, that will be 0, 0, 1, like that, since that's the difference there. So this multiplied by 27, then you're adding it by what? 27. So if I add this, all this, multiply, add, I just end up with 27.027. So this is what I get here. I can do that even on my calculator, just say 3.003 cubed. Then I see I'll get something like, if you use your calculator, you get something like 27.027009, like that. So this is a very good approximation of that. All right, let's move on. Okay, so now what am I going to do next? It's this one. We have 1 over 99, 999. So in short, we say that let our f of x to be equal to, that will be 1 over x. Your a, something very close to that, is just going to be 1000. So 1000, close to that. So when you do f of, you do f of 1000 there. So 1 over 1000, and that just gives you, so 1 divided by 1000 gives me 0.001. Okay, 0.001. Then I have f prime of 1000 is what I want to get next. So I have 1 over x. So 1 over x is just the same as this here. So if I differentiate this, I get negative there. Then of course I'll get x to the -2, which can be written as -1 over x squared. So this is what I get. Then that's what I'm saying, that I'm -1 over 1000 squared. So that's 1000 squared, like that. So what do I get here? So I square 1000. Then I divide that by 1 divided by 1. The answer, I just get this would be negative 0. That would be negative 0.0000001. So that's what I get, negative 0.00001. Okay, so after getting this now, so you have your f prime evaluated at 1000. Find that change, that is x minus a. So your x, in this case, our x is what? Is 99. So you're saying 999, then minus the 1000. This gives you -1. Then you can replace now everything. So 1 over 999 is going to be, so f of 1000, there is this here, which is 0. So approximately, since it's approximately, it's not what it's equal to. So that's 0.001. Then plus f prime, that's there, 0.0000001, then multiply by -1. So this becomes positive, and you're just adding the two. So you're adding this and the positive variant of that. So that gives you 0.0010. The one was not on the third one, then 0.0001. So that's what you get to be your answer. And of course, that is really a good approximation of what you get. All right, so that's how you find that. Next, what do we do? Next, we have question 5 here. Hope you're excited. They're telling you to use the mean value theorem to prove that tan x is greater than x, then 0x less than pi over 2. 0x less than pi over what? Over 2. Okay, so now how am I going to do this one? So I use the mean value theorem again. So now I'm saying I'll use g of x now. I've used a lot of words. So g of x to be equal to, if I take this x, the other side becomes negative. So I want it to be equal to tan x minus x. Tan x minus x. That there, and they're telling us that meaning tan x minus x is greater than what? Than 0. That's what I've just done here. So I let it to be there. Then look at the interval which I've been given, 0 and pi there, pi over 2. So I know at 90 I can't evaluate this because it's what? It's undefined there. It's undefined there. So I then just use f prime of versus I just evaluate it at 0. So of course, tan 0 is 0. So if I evaluate it at 0, this here gives me 0, that gives me 0, so I just get 0. I can't evaluate it on the other side because that there just gives me something that's undefined. Okay, so then I get now prime. Remember, you have the prime part of your C, is what you're saying. So f of x prime of this, what is this going to give me? That's sec squared. That's if I so if I differentiate tan x, that's 6 squared x. The x, I get 1 there. So this, of course, is just an identity which is the same as tan squared x, like that. And of course, this here is going to be giving value that is what? That is greater than or equal to what? Equal to 0. So greater than or equal to 0. So now, so for x, that is for x between what? That is for x in that interval. So x in the member of that interval, that is x pi over 2. Of course, not exactly at those endpoints, because here it won't be versus, but in between there, this here is going to give me something that is what? That is positive. So g is increasing, and as you can see that g of x is greater than what? Greater than g of 0, which is 0. This here is going to be greater than what? Greater than 0. Hence, we have that tan x is going to be greater than what? Greater than the x. Tan x is going to be what? To be greater than x. Okay, and that is for the what? For this interval which we've been given here. So this, it has followed directly from what? From the mean value theorem, which we have used here. So okay, this now. So if we just have if I had this here to find the square root of both sides, you see that I just remain with tan what? Tan x being greater than what? Being greater than 0. But this here is just what? This is my g. This can be my g of x because of that there. So then that is 0. Now the whole g of x being given this is greater than what? Greater than 0. Hence, this here is going to be what? Greater than 0. For every value we put in, it's going to be what? To be greater than 0. This here is going to hold for this interval here in between there, because I'm just taking the x and the other side. All right. Next, they're telling us examine each of the following geometric series for convergence. If the sum converges, find its sum. So what do we need to know? So for this geometric series, a GS series, or a GS, that's geometric series, then what is this going to be? So I'm saying this here, generally, we are going to have saying n beginning at 0 to infinity. Then you have a r raised to the power n. This will converge if and only if the common ratio is less than 1. So if this series here has a common ratio less than 1, the absolute value of the common ratio has to be less than 1, then it's said to be what? To converges. So this will converge. Then the sum is just going to be given by A. A is the first term, then 1 minus R. R is the common ratio. A the first term, R the common ratio. So that's what we're going to do here. So we look at here. Look at this closely. So your first term is what is A. So your first term is what is A. So what do you first have to examine here? So that for the first one in A, in part A, our common value, or our first term, I mean, is A, is 1. Then our common ratio. So the common ratio is what this each term has per se in common. Each term, that is from the first term to the next one, what is common. Now, so you see that this here, what the ratio which is common is 1 over what? 1 over 3. I mean 1 over 2 is common. So in each and every one of them, I have a 1 over 2. You can see that I have a 1 over 2. So on the second term that follows, they have there 1 over 2, plus the one that follows, they have 1 over 2, like that. The next one that follows, 1 over 2 over 4. So this here continues in the series like that. So that's my common, that's the common ratio, which is there. So, okay, so the common ratio is half for this one. So now I take my half, absolute value of half, which is the common ratio. This is less than 1. So meaning the series does converge. So it converges. After converging, now I can find the sum. So the sum is then first term 1 over 1 minus the common ratio 1 over 2. And just working this out, you get 2. Okay, so because here subtract there, you get half goes, it's 1 divided by half, and that 2 just goes there, so you get 2. Okay, next let's see what others have to offer for us. Next, again, first term is okay, so first term is 4. This here is how they are moving, and not that it's 4 minus 1, but the sign is alternating. It's an alternating series with a sign. I mean, sign is alternating there. What is the common? What is for when you look at all this going this side here, the common ratio there is just negative 1 over what? 1 over 4. That is the common ratio which we're having. 1 over 4, negative 1 over 4. You can check that there. It is obvious. Then what is the modulus of that? Is it less than 1? Yeah, 1 over 4 is less than 1. So meaning that this does converge. So the sum is then going to be first term 4, 1 minus 1 over 4. And this here is just going to be 4, 1 plus 1 over 4, which then just simplifies to it's 5 over 4, 16, so 16 over 5. So this is what you get. Okay, next. Okay, next. So next first term is 1. Common ratio. What's our common ratio? So you look, see every one of them here has a 3 over 2 in common. 3 over 2 in common. And there, 3 over 2. 3 over 2 follows just like that. You see it's a common, that's the common ratio. Okay, now is this the absolute value of this? Is it less than 1 or greater than 1? So this is greater than 1. So meaning it diverges. So we can't find the sum here because condition is only when it converges that we should find the sum. So it diverges, so we leave it here. So it grows without bounds. Right, so we start the last question for this session. Okay, which seemingly has a lot to do, but we're still gonna do it. All right. Now, first one, we have summation. Okay. So summation from n to, that's 1 to infinity, and then that is 3 negative n to the power n. So this is a geometric series. Of course, I can write it as n1 infinity. That's 1 over 3 to the power n. So 1 over 3 then to the power n, what is that gonna be for me? So I'm gonna have that this here is just, okay, so as I can see, it's a geometric series because when I put in, I'm just going to have 1 over, if I put in 1, I'm starting from 1. I'm starting from 1. So when I put in 1, I get 1 over 3. So in short, I get like 1 over 3. The next one is going to be going like that. That would be 1 over 9, 1 over 27, just like that, like that. So this here then, question is still find the sum of each of them. So the sum, is just the first term, which is 1 over 3, divided by the 1, divided by 1 minus the common ratio is the 1 over 3 here. Then you get 1 over 3 on top. Then there, that is bar 2 over 3, 2 over 3. Then that would be 3 divided by 2, just gives me half. Yeah, so I get 1 over 3 multiplied by 3 over 2, which just gives me half. So this here, the sum is half. All right, so that was the easiest one, and this one, the rest are so involving. All right, but still do it. Okay, so that's from n to 1, 1 over 2n minus 1, then I have 2n plus 1, like that. So what do I do here? So I'm going to resolve it into partial fractions, which is this part here, this part, resolve it into partial fractions. So in short, I'm going to have 1 over 2n minus 1, then I have 2n plus 1, like that. And this is going to be a over 2n minus 1. Then I have plus b over 2n, 2n plus 1. Right. So now, this one, so easy. So now can cross multiply this. So 1 is going to be equal to, if I cross multiply there, I get a to n plus 1 plus b to n minus 1. I can simplify it first. How? I say maybe I'm gonna get a 1 this side. So getting a 1 here, my n, meaning I'm letting my n. So let my n to be equal to half, such that I get 1 there. So n equal to half, I get 1, then I just have this will be a. If this is half, I get 1 plus 1 gives me 2, so this gives me 2. There I get half, 1 minus 1, that there just gives me 0. So I remain with a, and this will just be a to 1, and this here gives me a to be equal to 1 over 2, 1 over 2. I can do the same here. Say I'm going to put negative half, n, letting n to be negative half. So this here becomes 0. Then this side here, I get negative 2b to be equal to 1. Then I just get b is going to be equal to negative 1 over 2. So those are the two values that I am going to get. Then I can replace them. Just replace them. Just replace them. Yeah, be happy. The exam is coming. Be happy. Okay, so I found a to be half and the other one to be like that. So okay, so I can actually factor out that half, writing it because they all have half. So I can write it outside here, and of course it's just multiplying. Yeah, you're multiplying it on the top. You factored it from the top, so I write it smaller like that, like this. So there, meaning I remain with 1 where there's a. 2n minus 1, such that when I multiply here, I get the half. Here, there's the minus from the negative, such that here should be negative 1, and that 2n plus 1 like that, such that when I multiply this, I get the negative half from the b. So this is what I get. I've simplified it to be like this. So the form which we are saying is the nth partial sum. The nth partial sum, because you've done it into partial, you've made it into a partial fraction. So you're getting the nth partial sum. So let me erase this here now. So what does that even mean? So now this just means I write it as Sn, as nth partial sum. So the half goes in front, then I get summation that is from n equal to 1 towards to n. Since you're saying nth partial sum, then you're saying 1 over 2n minus 1, then you have minus 1 over 2n plus 1. So this is what you have there. So now, so write out the first few terms. So to write out the first few terms, so first few terms of this is just going to be half, then you're multiplying first few terms. So I start from 1. I start from 1 there, here. That is, if I put 1, I get 2 minus 1, that gives me 1. The other one, I get 1, that 1, and that'll be just like minus 1 over 3. Then it goes on. The next one, so this is like the first pair, that is when n is equal to 1. Then there you get like, if it's 2, that will be 4 minus what? Then I get 3, 1 over 3. Then that will be minus 1 over 5. So this here is when n is 2. Okay, that's when n is 2. Then I have plus 1 over 5 minus 1 over 7. That is when n is 3. So this is plus, blah, 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 and this is just going to be going. And of course, you're saying for 2n minus 1, then minus 2n plus 1, like that. All this is multiplying by half. So this is what you get. So those are like the first few terms. So everything cancels except the first positive one. Everything else will cancel. How? Because you see that this here is the negative half, and this here, they will cancel. This there and that there, the subtract gives you 0. This here up to the last was 6. So that one, not up to the last, but we're saying they will continue to cancel here in between. They cancel, and will remain with the last part, the negative part here. So what just remains here? In short, what I'm saying is Sn is going to remain with half. Then you have 1, the first term, it won't cancel with anything. Then you have the last part there, which will also not cancel. That is Sn plus 1, like this. So this is what you remain with. Now, here we can actually just say, okay, if we say that n, we handle that n. So that n, we're saying take, so as n approaches, so n, if we take n to approach negative infinity here, in short, more like we're taking the limit. This is just going to be s. So s is going to be what? Just to be the sum, in short, is going to be half over 2. Then n here going to infinity, n going to, yes, so n there going to infinity, you get 1 over infinity is just going to be 0. Then so you have 1 over 0. And this here is going to give you half. So like that, that's going to be your sum for this one. All right, very involving, but we're done. Okay, let's do C. So C, summation from n equal to 1 to infinity of 1 over n plus 2. Okay, partial again. So you have 1 over n plus 2. Now, this one here, just a over n plus b over n plus 2. Right. Now, this one, it's going to be, so that's 1. Then you have a n plus 2. Then you have b n. So if I say n is equal to 0, so if n is equal to 0, then I'll just have that This gives me a2 equal to 1, then I have a equal to half. So I have a equal to half. Okay, so that's when n is what? Is 2. So now, what if I say n is equal to -2? So when n is -2, I'm just going to have that 1 there. This here gives me 0. Then you have like that. B is going to be -half. All right. So now, writing this, so the 1 over n plus 2. So the 1 over n, so 1 over n. Oh, yeah, of course, just like the same. I guess we just factor it out, of course. So here I have 1 over n, then that's minus, because that's the negative half here. I factored out the 1 over n, so that would be negative n plus 2. So now, again, meaning we go in the fact that we're talking of partial sums here, because we have done partial fractions. So meaning that the partial sum, Sn is just going to be, Sn is going to be equal to partial sum. Just write it. Yeah, so that's half, like that. In fact, moving it to the front, so n to 1, infinity. Then I have S is gonna be 1 over n minus 1 over n plus 2. This actually just looks similar to what we are from doing. Yeah, looks similar to what we are from doing. And then you can see that if we write this up or we start evaluating it, it's just going to be, the first one is going to be 1, because that's at n. So you have 1 there, then minus, let me write it like this. So that's 1 minus the other one, that's 1 over 3, like that, plus, then you have 1 over 2, minus, that will be 1 over 4, plus 1 over 3, then minus 5 over 4, and just like that, this is continuous, like that. So now, this is a telescoping, it's telescoping. So it leaves the first two positives. So when you continue with this, you see that at some point, you see this part here, this will cancel with this one. You go again, you find something, you find the 1 over 4, it will cancel. So it will leave you with the first one. That's the positive 1, and and the half. That's what is going to leave you. And the last two. So with the ones with the negative and cancels the middle terms, of course. Then with the negatives, that remains, that's 1 over negative n plus 1 minus 1 over n is going to remain. So in short, what I'm saying is that Sn is going to be 1 over 2, then 1 plus 1 over 2 is what is remaining from the numbers in between. Then minus, we're saying, if depending on what term you're going up to, so meaning the n plus 1 minus 1 over n plus what, plus 2. These here will be the negative terms that are going to remain. Okay, so we wrap this. Okay, so now this here, what does this then mean? So but we know that n is going to infinity. N is approaching infinity from the question which we have here. So which means what? The last two here, as n approaches infinity, this and that there, this becomes zeros. Then what I remain with is just S, and the sum is just going to be 1 over 2. That's as n approaches infinity, of course. 1 over 2, then I have 1 plus 1 over 2. Then this here just gives me, I add this here, I get 3 over 2. So I'm multiplying 3 over 2 divided by 2, and that there gives me 3 over 4. So that is my sum there. Okay, next, and the last one is, so you have summation from n equal to 1 to infinity. Then you have 1 over n n plus 1, n plus 2. Right. So yet again here, we're gonna work out in a similar fashion, where we do decompose it, expressing it into partial fraction. So what is convenient is decomposition, is to express this as a difference of two simpler telescoping terms. So note that there you can use the identity which we're saying that n over n plus 1 and n plus 2, this here to be equal to half over that is n plus 1, n plus 1, then n plus what, 2, like that. So yeah, you can verify this by combining the right hand side to a common denominator. We also know from what we are just from doing in that or similarly to what we're from doing in the last question, that 1 over n plus 1, this here is just going to be 1 over n, then minus 1 over n plus 1, that we know. So that now, where that is, we can just replace what? We can replace what we already know. So which is this part here, we can replace. So meaning this here, the left-hand side, is just going to be half. Then this part which I know, I can then replace to say that is 1 over n minus 1 over n plus 1. Okay, then that is minus, then minus what we have there, that is 1 over n plus 1. Okay, minus, I've resolved this into partial fractions already, that is 1 over 2. Can verify this, and like that. All right, so simplifying, like if I simplify what is inside, you see if I multiply this by a negative, get negative 2, so this will be positive. Okay, this here is going to be negative by this which is negative. Then what do I get? So I get like n plus 1 over 2 to negative 2, of course, which I can say 1 over n plus 2. I move the 2 there, but this is multiplying. Yeah, so just simplifying what's inside. Nothing complicated, just follow it through. Simplifying what's inside. So 1 over 2, we're saying the first part is 1 over n. Then I'm saying minus 2, multiplying, just leaving it like that. So that's 1 over n plus 1. Okay, then that I have like 1, then that would be 1 plus n over 2. That's when this multiplies with that. Yeah. Okay, so now from here, what do I then do? Okay, so here, what I then do is, so, but of course, I'm saying it's telescoping, clearest first difference of this form. So again, going by what we said as partial sums, as what? As partial sums of what this has been said to be. So that is so if you can see that this part and that part is what I had written to be this. This is this, still there. Then negative or minus the 2, then I have the n over 2. So in short, I'm saying that the Sn is just going to be 1 over 2, starting from n equal to 1 to n, and this here can simplify it as n plus 1. that is following from here. That is that this is equal to this, and that is there. It's clearly seen. And minus. Then the other part, they are just going to be n plus 1, then n plus 2. Okay, so then what do I do next? So computing this pairwise. So okay, computing this pairwise, of course, you notice that what is just going to remain for this one. Of course, that's the summation. I remove this part here. So 1/2 here. Then now, if I start from 1, replacing that's 1 over. Okay, so that's gonna be 1 multiplied by the 2, like this. All other terms this side are going to cancel, apart from the last 2 terms, which are just going to be the same, n plus 1 like that, and then this multiplied by n plus what, plus 2. So like that's what I'm going to get. Now I get, as n approaches infinity, because it's an infinite sum that we're trying, or an infinite series that we are saying, then this here is just going to be that the sum is going to be equal to, this is half, that there gives me 0, then I just remain with what, with half over 2. Then this here is going to be 1/4 as the sum. All right, so this is how you work this out. And that is the last question for this video. Okay, if you are new to this channel, remember to subscribe. But also, if you want to register for online lessons, online tuitions, and to get full solutions to this tutorial sheet, because I've only gone up to question 7, go to get full solutions, access to full solutions, which will only be shared on the website. You can visit, that is discrete learning, learning institute, discretelearning.com, discretelearning.com. Okay, so you can just open your browser, and you open your browser, and okay, what is this that is happening here? So you open your browser like that. So when you open your browser, I already have it here, but you can type there to say discretelearning.com. Then when it comes here, then you sign up and register for an account if you've not registered. Then if you have registered, subscribe to the course which you'd like. Then so subscribing to the course. Okay, so subscribe to the course which you would like there. Then it will bring you one here. Let's say if you want to enroll into this course, then you say subscribe here, then it will show you the amount that is there for you to subscribe. You click on that course there, then you proceed to make payment, and you get a prompt from your phone in order to make that payment there. So this is how you do that. All right, and I am gonna see you in the next one.